Today we'll be going over the homework for targets 3 through 5. Please make sure if you have any extra questions you refer back to the notes. So on 1 through 4 they want us to state the degree, the type of the function, and the sign of the leading coefficient. Remember, the degree is always the biggest exponent in our polynomial. If that polynomial were written in standard form, it would be up front. So the degree of this polynomial is going to be degree 3 because 3 is my biggest exponent. Since 3 is my biggest exponent, I know the type of this polynomial is going to be a cubic. The sign of the leading coefficient, you always look at the number in front of your degree. So 9 is going to be my leading coefficient. 9 is positive, so my sign is positive. If we look at number 2, on number 2, the degree here is going to be 4 because that is my biggest exponent. Type, I know if it is degree 4 that it is a quartic. And the sign of my leading coefficient then, again, we look at the number in front of the variable with our degree. That is a positive 9, so my sign is positive. On number 3, my degree, well, we don't have an exponent on our variable here, so we know that would be a 1. So this is going to be a degree 1. If it's degree 1, we identify it as a linear. And then the sign of my leading coefficient, well, the number in front is a positive 4, so my sign is positive. Number 4 then, my degree, so again, looking for that biggest exponent, my biggest exponent is 2. The type, if it is a degree 2, then it is going to be a quadratic function. The sign of my leading coefficient, this one has that negative 5 in front, so my sign is negative. On 2 through 8, we need to do our end behavior. Remember, when you do end behavior, you have to use that correct notation. So on every single one of these, we'll need x approaching positive infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? So again, you need to have that every single time that you write your end behavior. So all 4 of these, their final answer should be written with this notation. So in order to find this, remember the 2 things we care about is our degree and our sign. So when I look at number 5, my degree is 3, my sign is negative. So my degree is odd. So for me, I would always think of a linear graph because I know linear represents odd. My sign is negative, so a linear with a negative slope would be starting going up to the left and then down to the right. If you've memorized that table, you can also just think back to that. So as x approaches positive infinity, tells me as I go to the right. As I go to the right on my little sketch, I'm going down. So I'm going towards negative infinity. As x approaches negative infinity, tells me I'm going to the left. As I go to the left on my little sketch, I'm going up. So I'm going towards positive infinity. On number 6 then, my degree here is 2. So I know that would be a quadratic. I know that is an even degree. My leading coefficient, or the sign on it, is a positive 1. So even tells me to think of a quadratic graph. Sign being positive tells me my quadratic graph would be opening up. As I'm going to the right on my graph, so as I'm going towards positive infinity on my x-axis, my graph's going up, so I'm going towards positive infinity. As x approaches negative infinity, as I go to the left on my graph is still going up. Remember, those even degree functions will always either both be going up or both be going down. Number 7, my degree here is going to be a positive 4, my biggest exponent, which tells me I have an even, so I'm going to think of a quadratic again. My leading coefficient on this one has a sign that is negative because my leading coefficient's negative 1. So I would think of a quadratic since it's negative, opening down. using my correct notation. So as x approaches positive infinity, f of x, my graph is going down to the right. So f of x approaches negative infinity. As x approaches negative infinity then, or as I go to the left on that graph, it is still going down. So f of x approaches negative infinity. Number 8 then, if I look at my degree, my biggest exponent here is that 5. It is in standard form. That's an odd degree. My leading coefficient then would be a positive one, so my sign is positive. If it's odd, I think of a linear graph. A positive leading coefficient tells me to think of a linear with a positive slope. So as x goes to positive infinity, or as I'm going to the right of this graph, my graph is going up, so f of x approaches positive infinity. As I go to the left on my graph, as x goes towards negative infinity, I can see that my graph is going down, so f of x approaches negative infinity. On the back here, it wants us to state the domain and range of the function. So domain of this first function, remember my domain is going from left to right because my domain is my x values. This graph goes forever to the left and it goes forever to the right, so my domain is all real numbers. My range on this function, it goes down forever, but my graph does not go up forever. It stops here at a -2. So my y values need to be less than or equal, since I'm going down, to -2. If you like your interval notation, it's from negative infinity up to a -2. Remember, your infinities are always in parentheses. Since I have a point at -2, that will be in a bracket. On number 10, again, this graph is going to the left forever, and this graph is going to the right forever, so my domain here is all real numbers. This graph doesn't go down forever like that first one over there, but it does go up forever. It only goes down to -3, so I need all my y values that are greater than or equal to -3, or -3 to positive infinity. We can also identify the type of these two graphs. So this first graph on number 9 is going to be a quadratic because it is that U shape. On number 10, we have the kind of that W shape. It's not always going to be a perfect W, but it does have that W shape. So this is our quartic graph. On number 11, we're not going to be able to identify that type. It kind of looks like a cubic, but that extra hump in there will actually make it something different. But our domain, I can tell that this graph is going to the left and it is going to the right forever. So again, my domain is all real numbers. Remember, we said all of our polynomials will have a domain of all real numbers. It doesn't matter if they are even or odd. My range for this graph, well, this graph is going down forever. This graph is also going up forever, which tells us it would have an odd degree. My range here is going to be all real numbers. All odd degrees have a range of all real numbers. The graph goes up and down forever, so it hits all of those y values. Last but not least, number 12. Number 12 is continuing to have that domain of all real numbers. The x values go to the left and right forever. Number 12 also has that range of all real numbers. My graph is going up forever to the left, it's going down forever to the right, so it's going to hit all of the y values in between there. If you have any questions, please come in.